Hello. We'll be starting off with derivative of trigonometric functions. And what are trigonometric functions? Are just functions working with our sine, our cos, our tan, our cot, sec, and the rest. So let's start with the basic ones because actually all trig functions came out from just these two. That is sine, x, and cos. So our sine and our cos are actually the basic trigonometric functions. So we have our sine and our cos. So let's write our y is equal to sine x. And if you find the derivative of y equal to sine x, actually is going to give us dy dx, which will be giving us what? Cos x. So therefore, whenever you are given to find the derivative of sine x, we know it's going to give us what? Cos x. Then when we have our y is equal to cos x, the derivative of cos x will give us what? Dy dx, which is equal to minus sine x. Then what about finding for our y equal to tan x? Now to find for tan x, in fact let's solve for this particular one. To find the derivative of tan x, we know that tan x can be written as what? Sine x over cos x, right? From your spatial angles, from your trig formulas. So how do we solve this? If we're to find the derivative of this particular question, we know that this will bring us into what? Quotient rule, right? Yeah, quotient rule. So this will give us quotient rule. Why do we say so? Because we are seeing a function dividing on that function. And what's the formula for quotient rule? It tells us that our dy dx is equal to v du dx minus u dv dx over v square. So therefore, bringing it in, let's find our v and our u and then the derivative of v and u. So our u here will actually be the top one, which is our sine x. Then what will be our v? Our v is what? Our v is cos x. And according to what we've shown here, what's the derivative of sine x? That will be for our du dx. Our derivative of sine x is what? Cos x. So we have that as cos x. And our derivative of dv for our v will give us what? Minus sine x. So putting into this equation, we have that our dy dx is equal to our v, which is cos x, multiplying our du dx, which is cos x still, minus our u is what? Sine x, multiplying our v, our dv dx, which is what? Minus sine x. We have minus sine x all over our v square. So that's cos x square. Now please, I would like to talk about this at the side. Whenever you have let's say sine x square is actually equal to what? Sine square x. So you can take your square or whatever value as a power and bring it inside your sine or inside your tan or inside your cos, whichever function you want to work with, either sine, anyone you can bring into your trigonometric function. So this is the same thing with this. So therefore we'll do the same thing in this particular case here. So we have this as what? For cos x times cos x, we'll have it as cos square x, right? So that'll be cos square x minus and minus is actually plus. So here's plus. Sine x times sine x is what? Sine square x over here will be what? Cos square x. Now what is cos square x plus sine square x? According to trigonometry, we know that whenever cos square x adds up with sine square x, it will be equal to what? 1. So we have it as 1 over what? Cos square x. But are we to stop there? No. 1 over cos x, actually in trig, we know that 1 over cos x, let me put that somewhere here. We know that 1 over cos x in trig is actually equal to what? Sec x. And 1 over sine x is actually equal to what? Cos sec x. It's good you know all these things, all these signs. So we know that since we're having 1 over cos x is actually sec x, then when we have it as cos square x, it will be what? Sec square x, right? So therefore 1 over cos square x here will give us what? Sec square x, which is your dy the x of your tan. So we know that the dy dx of your tan will give us what? Sec square x. So let's come into this and write it out. So we can write it out here that dy dx for tan is equal to what? Sec square x. So that is it. Now let's take more examples to solve so that we can get a more understanding of what's happening. Okay, so let's take this particular question. If we have our y to be equal to x sine x, Now this particular one, what rule are we to apply? The product rule, right? Because we're seeing a function multiplying another function. Therefore in product rule, let's bring out the formula is dy dx is equal to v du dx plus u dv dx. Hence, what do we bring out our u and our v in this case and find the derivative. So our u will be x, our v is actually what? Sine x. Then our du dx will be what? 1 in this case, because when you differentiate a value that's singular, it gives you just 1. And then our dv dx, the v dx is what? Cos x. So bringing to this particular the formula, we have the dy dx is equal to, what is our v? Our v is sine x. And what's our du dx? Du dx is 1 plus our u is what? X, and our dv dx is cos x. Cos x. So that is 1 times sine x, which will give us sine x plus x cos x, and that's the answer. Let's take another example again. We have this particular, this one is actually interesting. We have 4 tan square 3x. 4 tan square 3x. Now, before you can attempt to differentiate a particular value that has a square inside it, the trigonometric sign, first take out the square outside, or take out the power outside. So therefore, this will be actually what? 4 tan 3x, and then you put the power outside. It will aid you in your solving, and this for y. Now, this particular case tells us about to apply what rule? Our chain rule, right? Because we are seeing a power outside. Therefore, we know that our dy dx for chain rule is actually going to give us dy du multiplying du dx. So the next thing we have to bring out is what is our u in reference to what y. So we know that our u, let our u, so let me write let u be equal to what? Tan 3x. So our u is the value inside. Then our y in this case will then be equal to what? 4u raised power 2. So we can continue by saying that our dy dx then, so let's find the differentiation first of all. So to find the differentiation, let's take for what is the value of dy du. Dy du will give us what? 2 multiplying 4 will give us 8u, and our du dx will give us what? To differentiate tan 3x, how do we do it? This will also give us another chain rule inside it. Let's solve this one outside here. We have tan 3x, and now let's put a y equal to tan 3x. In this particular case, we can say that let our u again, let a u be equal to what? 3x. Therefore, our y is equal to what? Tan u. Hence, in solving this particular question, what do? We say that our y, our dy dx is actually equal to what? The y du multiplying du dx. Next, we find our dy du. So what's the differentiation of tan u? It will be what? When you differentiate tan u, remember when we differentiated tan, we got what? We got sec square, right? So it will be sec square u now. So here will be what? Sec square u. And when you differentiate 3x, what do you have? You have just what? 3. So we're actually having what? 3 sec square. But what's our u? Our u is what? 3x. So 3 sec square 3x. So therefore, that's what we have as a value for here. So let's repeat it again. 3 sec square 3x. So bringing it into our formula for chain rule, which is this, we have our dy dx is equal to our dy du, which is what? 8u multiplying 3 sec square 3x. So what do we have? 8 times 3 is 24, and then our u, what's our u? Our value of u of our u is what? Our value of our u is 10 tan 3x. So we have it as what? Tan 3x. Then what's our then we have here, sorry, sec square 3x. So are we done? Nope. We can still go further. Let's go down. We can go further by simplifying this the more. Now we can write it as 24, which is still 24. But what is tan? Tan can be written as well sine over cos, right? So yes, sine 3x over cos 3x. And then our sec square can be written as what? Multiplying by 1 over what? Cos square 3x. So notice something, cos 3x can multiply cos square 3x, and that will give us 24 sine 3x multiplying 1 over cos raised to the power of 3, because this will now make it raised to the power 3, 3x. So what is 1 over cos raised to the power 3, 3x? You can write it back as what? Sec raised to the power 3 now, no longer raised to the power 2. So that will be equal to what? 24 sine 3x sec raised to the power 3, 3x. And that's the final answer for our dy dx. Let's take one last solving, and we can pull it off. We can call it off for trigonometric functions. So if we're given to solve this particular question, okay, I will take two actually. So let me take the first one, where y is equal to cos square root of x. Now to solve this one, the first thing you have to do is to do what? Convert this square root of x to its initial form, which will be what? Cos raised to the power 1 over 2. That's like that. Sorry, let's put that very well. They're saying it's like saying cos x raised to the power what? 1 over 2. And remember I told you this will be in what? Bracket, raised to the power bracket. So now that's like this, you can then solve by bringing out, this is actually a chain rule or function of function, whichever you want to call it. So remember what is function of function rule? The y dx will give us the y du multiplying du dx. So we have to first bring out our u. What will be our value of u? To be the one inside, that will be what? Our cos x. And then our y will be equal to what? U raised to the power of 1 over 2. So when we differentiate our u, that's for du dx, what do we have? We have minus sine x for cos x. When we differentiate cos x to give a minus sine x, and when we differentiate our dy with respect to du, what do we have? We have that half will come down, which is 1 over 2 u raised to the power of what? When you subtract 1 from here, you have what? Minus 1 over 2. And I can easily put this down to look like this: 1 over 2 multiplying 1 over u raised to the power 1 over 2. And also I can write it again as 1 over 2. Let's just put this down: 1 over 2. So let me arrange it very well. 1 over 2 u raised to the power of what? Square root of u, sorry, the square root of u, because 1 over half is square root of u, right? So let's now bring this into the solving. Into the solving, we have, remember this is our formula we're using. Dy dx is equal to dy du multiplying du dx. So bringing it in, we have that our dy dx is equal to, what's our dy du? Dy du, we got it as 1 over 2 square root of u. So it is 1 over 2 root u multiplying our du dx. What's our du dx? Is minus sine x. So we have that's minus sine x. So that will be what? Minus sine x over 2 root u. Our root u will actually be what? Our u is cos x, so let's put that cos x in square root sign. But remember, what is our root sign? Our root sign can be reduced to be saying minus sine x over 2. Remember what happens here? This can be written as what? As cos square root of u. So this is, sorry, cos square root of x. This is x, not u. X. So this is our final answer for dy dx. And then lastly, the last question I'd like to take before we call it off, the last question I'd like to take, that would be, if we are given to find y is equal to 1 over sine x. Now to solve this particular question, you just need to just use the initial form. in indices, when you have 1 over anything, is can write as what 1 over what sine x raised to the power of what minus 1. And now you can easily solve this by using the chain rule. So applying the chain rule, we know that our dy dx is equal to dy du multiplying our du dx. So what's our u? Our u here is sine x, and our du from it, du dx from sine x is what cos x. Our v again here, our y is then what? Our y is u raised to the power of minus 1, and our dy du related to u will be what? Minus u raised to the power of minus 2, right? Therefore, bringing it into the particular equation, that's this equation here, we have that our dy dx is equal to dy du. Our dy du is what? Minus u raised to the power minus 2 minus u raised to the power minus 2 multiplying du dx, which is what? Cos x. And that will be what? Minus our u is what? Sine x. So we have that sine x raised to the power of minus 2 cos x. So I can apply the negative index law here and take that down. That's my dy dx is equal to minus cos x over sine x raised to the power of what? 2. And then remember what happens here, I can bring this my sine into my square inside, and that will be minus cos x over sine square x. So I can stop here, or I can even go further by finding that that this can be broken down to like writing cos x over sine x multiplying sine x, right? Yeah, because we know that this, when they multiply, I have sine square x, and now cos x over sine x will give us what? Tan x, right? So this is like writing what? Minus, remember there's a minus here, minus tan x, and then here is just having 1 over, so it's like multiplying by 1 over. So what is 1 over sine x is what? Cosec x. So this is cosec x. So it is minus tan x cosec x. And we'll stop it here. So this will be the end for trigonometric, working with trigonometric functions. The next one we'll be doing higher derivatives. That's when you're trying to differentiate more than once. So you differentiate something once and you differentiate it again. So after that, then we'll enter into our trigonometric functions. So thank you. See you in the next video.